In this video, we're going to go over how to find the derivative of an inverse function if we can't actually find its inverse. So just a recap, this is all stuff that should maybe kind of come back to you. But if it's an inverse function, we can compose the two functions, like plug one into the other, and everything should cancel out and we should be left with x. We should be able to do the opposite as well, take f and plug it into g if they are inverses, and again, we'll still get x. If that's true, then those are inverse functions. They are reflected across this line y equals x. So because of that, the y is equal to the x value. So on the original function, if a, b is an ordered pair, since this guy is x, in the inverse, it's now the y value when the y value is x. So domain and range, we just flip them. So that is a very, very important part of this. And that's kind of written out right here. So that's definitely something you absolutely have to know. When we see this notation that is read as f inverse, it doesn't mean f is to the negative first power, which does get confusing. But on the AP test, there is a blurb in the beginning that says that denotes f inverse. So again, it's a reflection. Domains and ranges are switched. It does have to be 1-to-1. And all that means is it has to pass the horizontal line test in order to have an inverse. So if I had something like a quadratic function, this does not pass the horizontal line test, meaning it crosses twice. So this guy does not have an inverse on its entire domain. So if we wanted to find an inverse function, we solve for x, and then we switch x and y. And we do have to make sure that we state our new domain so that our new function is 1-to-1. So that's all recap. The most important thing on this page is that your x's and y's will switch. So if it's an xy ordered pair on the original, it will be a yx ordered pair on the inverse. So first example, we're going to find the inverse and state the domain and the range. So again, we just solve for x. So if I had f of x here equals x minus 3 to the 1/2 power, I have to get x by itself. So I'm going to have to square both sides. So over here, I'm going to call this guy y. So I'm going to have y squared. And if I square this, that's going to cancel the 1/2. So I'm left with x minus 3. Lastly, I can add 3 to both sides. And I see that y squared plus 3 equals x. And then I just switch the x and the y. So my new function is y equals x squared plus 3. This is my inverse function. But I do have to make sure that I state the domain and the range. So in the original, okay, I cannot have a negative under the radical. So I need to think what would make that guy positive. If I plug 3 in, I get 0, which we can take the square root of 0. But if I plug in anything less than 3, like let's say 2, if I plug in 2 here, I get a negative under the radical, and that can't happen. So my domain would be for x is as long as x is greater than 3. It could also equal 3 because we can have 0 in there. And then when I do that, I'm going to get any value greater than 0. So in my new function, my new domain is my original range. So whatever my original range was is now my new domain. So as long as x is 0, this is the inverse function to the original. Okay? Sometimes we can't do that. So we cannot always solve for x. So remember, we were getting x by itself here. Unfortunately, that's not always possible. So if that's not possible, I can't take the derivative of the new function. So what I have to do is this formula. And this formula, yes, is something you probably need to memorize. The way I memorize it is I kind of look at what they ask me. I take these two and I switch them since it's an inverse. And I also put it on the bottom since it's an inverse. So that's just kind of how I memorize it. So imagine the original is over 1. So I kind of flip that. And then I flip the derivative and the inverse. So the derivative is now on the f. And then the inverse is inside. And so once you have this formula, it's actually pretty easy to plug and chug. This is a composite function. We always start in the inside in a composite function. So that would be something that I would have to find first. So here's an example. It asks me to find the inverse, then find its derivative, then plug in 5. So in order to find the inverse, I have to get x by itself, which cannot happen. That's why we have to use this formula. So the formula is over here on the box, and we're going to start right here on the inside. So f inverse of x is what I'm looking for. And in this particular case, we're plugging in 5. The question asks me to put a 5 in here, so that's actually what I need to find. And this says, find the inverse and plug in 5. But remember, we can't do that. So we have to use the original. And the property that we know about original functions is that if I'm looking at the original, these two are switched. So I'm actually looking for what x value gives me a y value of 5. And so this just says take the function, set it equal to 5. So if I set this guy equal to 5, and here's where you're probably going to be using your graphing calculator, you can graph the two to figure out where they are equal. And so we get x equals 2. So if we know that x equals 2 on the original, then we have to know that y equals 2 on the inverse. So if this guy's 2, that means the y value of the inverse is 2. And that's what I was looking for. So I needed to find the inverse of 5, and the inverse of 5 is 2. So I just plugged 2 in. So continuing out with our formula, we're going to have a 1 over the derivative of 2. Again, I just replaced the inverse with 2. Now this says take the derivative of the original function and plug in 2, and that we can do. So if we look over here, if we take the derivative, we just use the power rule, so we'll get 3/2 x squared plus 1. And now we're going to plug in 2. So f prime of 2 is going to be 3/2 times 4 plus 1. If I multiply and divide here, I'll get 6 plus 1, and 6 plus 1 is 7. So f prime of 2 is 7. So now we're going to plug that in right here. And continuing with our formula, we get 1 over 7. And this is equivalent to the derivative of the inverse right at 5. So even though we couldn't find the inverse, we can still find its derivative at a certain value. So this example we're going to skip. Here are derivatives of inverse trig functions. Again, it's just like the regular functions, where if you have an x here, you don't have to use the chain rule, but if you do have something other than x, you do have to use the chain rule. These you might want to memorize. Okay, so here we're going to take the derivative of the inverse cosine of x squared, and if we look back to the formula, the inverse cosine is going to be negative u prime all over radical 1 minus u squared. So negative u prime all over the square root of 1 minus u squared. So u is going to be whatever this baby is, okay? So if we plug this in, we'll get negative, and then u prime would be 2x all over radical 1 minus the entire value of that baby squared. And this would be the derivative of that guy.